Good morning students, myself Sushmita, Assistant Professor, Department of Electronics and Communication Engineering. So in this session we will learn about multi-core and shared memory multiprocessor. So on completing this particular video you will be able to understand what is memory multiprocessor. Also you will be able to explain about centralized and distributed memory, how it works in centralized and how it works in distributed memory. So on seeing about this memory architecture, you can see that this memory organization and the interconnect strategy mainly has two classes. So first class is that it can be either symmetric or centralized shared memory multiprocessor, and second thing is a distributed shared memory multiprocessor. So these two memory processors multiprocessors plays a major role in sharing the data or distributing the data from the memory. Another two important processor is that multi-core processor and the shared memory multiprocessor. So first thing is that multi-core processor. Multi-core processor is nothing but a processor that contained multiple processor. That is, in the previous video lecture we saw what is a processor and what is a multiprocessor. So if you still haven't watched it, just go and watch that video so that you can understand how multiprocessor are used in processing. That is influence classification video, you can check it out. So here the multiprocessor contains multiple processor in a single integrated IC, that is in a single integrated chip we will be, or a circuit we will be having multiple processors, that is in terms of cores we will be having. Another thing is shared memory multiprocessor. Shared memory multiprocessor is nothing but a parallel processor will be present within a single address. So that is called as shared memory multiprocessor. So you can see shared memory processor, we are having processor, cache as well as interconnection network, which are again connected to the memory and input output. So this is how the shared memory architecture looks. You can see that all the processor and the cache memory is connected to one common intermediate interconnection network, which is again connected to memory and input output. So now let's see about the centralized shared memory. So in centralized shared memory we are having different processors, as well as below that we are having one or more level of cache that is present. So why we are having cache is that cache stores the temporarily fetched data at that particular point of time, so that we can retrieve the data easily from that particular memory called cache. So that is the purpose or use of having cache memory, and then again it is connected to main memory or input output system. So this is how centralized shared memory works, that is we are having a centralized shared system of sharing memory. So what are the disadvantage of having this centralized shared memory is that first point is more complex interprocessor communication, as we saw that there are different types of processor and it is somewhat bit complicated to have between the communication between two processors. Since every processor is individually being connected, it is somewhat difficult to communicate within among themselves. That is the first point. Second thing is that more complex software to handle distributed memory. So we need some a bit complicated softwares to handle the distributed memory system. So that is another one disadvantage of using this particular centralized shared memory system. So next thing is a distributed shared memory. So distributed shared memory in simple words is mean that it means distributing memory among the nodes, which in turn increases the bandwidth and reduces the local memory latency. We have memory input output as well as the processor and cache, and we are having interconnection network in between them. So that particular interconnection network is used to connect or transfer the data from the upper band to the lower one. So we are distributing the memories among the nodes which are present in that particular system or architecture. That is the distributed shared memory. In this case, we are having two different access of memory. So first one is uniform memory access and second one is non-uniform memory access. So from the name we can clearly say that a uniform memory access is nothing but no matter which processor requests the access, it will be just going and granting the request. So that is the uniform memory access. But in case of non-uniform memory access, some memory will be accessing faster than the others when compared to the other memory access. So here this memory access time, it will be completely depending upon the word location in the memory. That is, if it is the fetching of that particular data is present nearer, or that is if it is can be easily accessed, then it is the time required for that particular data will be very less to be fetched. So this particular thing is it's completely varying and it will be depending upon the data word location that is being present in the memory. That is no particular or fixed time. So we are calling it as non-uniform memory access, but it will be very much faster than the other memory access system that is present. This particular system is called as NUMA. Another one feature is that synchronization. Synchronization in the sense we will be coordinating the behavior of two or more processor, or we will be having some processor which may be running on different processes. That process that is running on different processor, we have to coordinate how the two or more processes being done. All those has to be taken into consideration and synchronization is being done. That particular process is called as a synchronization. So the next feature, final one, is that it allows the data lock is nothing but we can access only one processor at a time. Okay, so for an example we can say as SISD, that is single input single data instruction. That is one of the good example of lock instruction. That is synchronization of that particular device will allow only one processor to access that at that particular time. I hope you all understood. Now we have a question on shared memory. So what is shared memory? Option A is that a computer architecture where all processors have direct access to common physical memory. Option B is that it refers to network based memory access for physical memory that is not common. And option D is that parallel tasks typically need to change data A through a several ways. This can be accomplished such as though a shared memory bus or over a network. However, the actual event of data exchange is commonly referred to as communication regardless of the method employed, and option D is that none of the above. So I hope you all had a very useful session on knowing how the memory is being shared in centralized as well as the distributed, and how the uniform and non-uniform memory is being accessed. Hope you all had a very useful session. Thank you for watching this video. See you in another video lecture.